Hello everyone, I'm Quentin Gauthier, I'm a 2 years PhD student, and today I will present an article submit at the 27th International Conference Information and Visualization. And we will talking about the representation of urban geometry evolution through a space-time cube. This article has been written by Johanna Delanoy, Gilles Jesquier, and me. So, Um, in a context where cities are always in a state of change, 3D representation of city or digital twins are become more available and helping a better understanding the organization of a district or metropolis. The, the metropolis or city try to have different version of the 3D representation to keep the history of the territory or to see the evolution through the data. But with this different version of the data, some question arise is how to represent the time to have the all the evolution in the same 3D space and to analyze in one specific view with all the changes on one specific view. The second question is how do we link the version of the data in a 3D environment? So you can see the example of Jayo and his colleagues, where they represent the 3D urban data on a specific time. Some approach try to visualize this evolution with the morphological changes, like I said, Jayo and his colleague approach. But also Deluca and his colleague try to visualize 3D representation and the semantic graph of the evolution of a building. The JUNL approach is more about the city or district. These two kind of approach are very interesting, but they represent the state of the data at a specific time, at a t time, but they didn't represent the whole evolution in one specific view. So it can be difficult to analyze the different version and to see quickly the differences between a large area. After that, another way, in geomatic, they use the representation of space-time cube to represent network data like workers' routines. Um, the specification of the space-time cube in geomatic, that is, they integrate 2D data in a 3D environment where the z-axis is the time. The time is integrated on the z-axis. So in the example of Gwen and his colleague, you can see on a metropole where the workers are to work, but also to go at their home. Or there is another scale with the Agastron method, where we have the routine of one worker, where there is some meeting, and after that there is some telephone call. So um, we have this kind of representation of the evolution with the space-time cube for 2D data, with the time integrated on z-axis. They can represent network data like worker routine, and that we have also with the JO method change detection between versions. But this kind of approaches or methods didn't can't permit to see very quickly where it is there is some changes and where there is some change detection on different building, and it's not integrated with the 3D urban data. So our method want to enhance the space-time cube of the geometric with the 3D urban data. We wanted to integrate different versions of the data along the z-axis, so integrate the time and also the coordinates in the three spaces, and link the different version of the data through the representation of the space-time cube. So now we can see a little video of our method. and we will explain the different interactivity we have with this representation, how we made this kind of approach. So you can see different interactivity with the changes, the different changes with the color, the construction. For green one is the construction, the red one demolition, and yellow one modification. You can also have interaction with one specific building. So, so now to how do we structure the data to easily display it in the 3D environment in the SDC? First of all, we have the version of the 3D city model. For Samuel and his colleague, a version is referred to state of data at a particular time. We have keep this definition. So we have, for example, on this schema, we have V1 and V2 that are two different versions of a building, and we call the difference between V1 and V2 a transaction. And we have four kind of transaction in our method. That is construction, modification, demolition, and unchange. So now we have structured the data. How can we integrate the different version in 3D space? How we can integrate time and 3D urban data in a 3D environment? So, as I said in the previous slide, we want to enhance the space-time cube with the 3D urban data. So we will integrate the z-axis will be the time, but also the coordinate. We keep the 8 of the z-axis. The different version of the city will be disposed along the z-axis. So first of all, we have this kind of representation. But now how we will displace this different version along the z-axis. So for that, we have made a little matrix transformation, multiplicate to the coordinate in the world position, multiplicate to the coordination, the world coordination. To be more in detail, we have x0, y0, and z0, that is the position in the world, where z0 is the initial position in 8 of the order 3D urban data, plus delta coefficient. It depends on several parameters. The maximum height of a building and the connectivity between versions of data. For example, we add this coefficient because if you have some skyscrapers in your version of the data, maybe the skyscrapers will be superimposed with the new one, on the top of your actual version of the data. So we need to add this little gap to place more space, and and the space typing will be more easy to understand, and etc. And multiplicates to the gap uh, between the two states of the data. So T1, uh, for example, TE can be equal to 20 and 15, and T0, so the oldest version of the data, can be equal to 2012. So in this example, this part will be 3. Multiplicate to delta, it can be different coefficient, plus 0 plus z0, that will be the initial position of the oldest data. So we have integrated different versions of space-time cube. Now, how we can integrate transaction time in a space-time cube? For that, we have these different changes. I'll calculate with the graph change detection explained in the previous slide. So to bring more comprehensibility of the space-time cube and have a quickly analysis of the space-time cube with the different version, we create a physical link between version to represent the transaction in the 3D space. So we have unchanged, where there is no specific geometry changes. The construction, where geometry appears between Ti and Ti plus 1. The destruction is the opposite, where the geometry disappear between Ti and Ti plus 1. And the modification, where the geometry has a specific, a little modification between these two states. So a first interesting proposition is shown on this image. We have tried the representation on the Gracial district in Lyon, in France. The district is interesting because we know that is some representation project during these different states of the data. And with this first result, we can quickly see where there is some changes, and the data analyst can explain very quickly where there is some data changes between this kind of version and etc. So to enhance more this kind of representation, we bring two modes of interactivity to have a finest, to be more precise in your analysis of the data. The first one is the selection uh, with a specific building. So your user can click on the building and you will the whole evolution of the building will appear in the area of the space-time cube. So you can have the unchanged. For example, here you can have the unchanged transaction and after that the destruction. You can see here. So you can have this authority can bring a very specific analysis of a building and see the whole evolution of this building. The second interactivity is um, is on transaction time. You can choose which kind of transaction you want to display in the space-time cube. You can select the construction, the demolition, or the modify. We didn't give the possibility to see the edges because it was not per pertinent in the kind of interactivity because we want more about one specific changes. And for example, here we can see easily that there is not a lot of construction in compare from the modification. Now we have improved our work on two different use cases. These two different use cases, the version of these two very different use cases come from open data of Lyon in France. So we have tried on the Gratte-Ciel district in Villeurbanne in Lyon. So we have a little video to show what kind of transaction there is and what we can see. So as I said, we can see the evolution of a building here with the modification. You can see also the different construction of this kind of district, and we can then with this analyze, we can see there is a lot of destruction uh, during 29 and 2015. Another use case, oops, sorry, is l'Adoua campus in Villeurbanne. As the previous use case, you can see there is we can see a lot of modification at the version 2018, but not a lot of construction between nine. There is only construction between 29 and 2012. So we can, with this kind of representation, where the data analyst need to have different action to see this kind of analysis. In this kind of representation, we can vary in one eyes in one specific analysis. We have different. We can see different changes in the representation. So to conclude this presentation, we're bringing a new tool for data analysts to see quickly the evolution of 3D urban data. We enhance the space-time cube used by the geomatician with 3D urban data. We have integrated the time in the 3D space, and we also have a new way to compare the different versions of 3D urban data. We have we bring more interactive about this kind of representation because there is with new features, it can be difficult to analyze more easily. So we bring more interactivity with the space-time cube. For the future works of this representation, we wanted to enhance the different version of the data with other representation of the city, like multimedia. For example, in my previous work, I have contextualized, I've integrated, we have in previous work, we have integrated multimedia on a specific position in a 3D space to contextualize more an area, a building, or some industry, etc. So maybe we can contextualize the transaction or the version with a specific document for a building, for urban project, or maybe why we have destroyed this building, why we have made some modification, and etc. To have a more to understand more the evolution of a district. Another way, we are thinking about another way to display the temporal slice, maybe with a different transformatics, not on the z-axis, but maybe on the in a circle. Can think of different way to display the version. And another future work can it could be interesting is a collaboration with workspaces graph made by Vinesco Thesis. Uh, Vinesco tried to have represent a graph of different scenario of data of the district, etc. Maybe we can enhance the representation of the city, the STC with different scenario of urbanization of district and see why we choose this kind of urban project and not another one, or maybe we have pick some building of the scenario A and integrate in the scenario B and etc. So that's it for the future works. Thank you for your attention, and all these project and modules are available on GitHub. We try to make it very reproducible, and if you have some question, I'm open to it.